Okay, final topic on coordinate geometry. We're going to look at how would we find this point of intersection. How do we find where two lines, or later on in A-level, a line and a curve, intersect? So let's just take the two equations which we had. 2y minus 7x plus 11 equals 0. And our other equation was 7y plus 2x minus 32 equals 0. Okay. Importantly, you can just solve this on your calculator. Always remember that your calculators can solve simultaneous equations and later on can solve quadratic equations. But we'll go through this one manually, just to remind you of the techniques required. We need to eliminate one of these variables. So in order to find where two lines or a curve meet, we solve simultaneous equations, and we do that by eliminating one of our variables. In this case, we're going to choose to eliminate the x. No particular reason other than this one's negative, that one's positive, so we can just add stuff together. So we're going to multiply this equation here by 2, to eliminate the x. And this one here we're going to multiply by 7. If we do that, for this top row we're going to get 4y minus 14x plus 22. Multiply all of your terms, not just the algebra. And then here we're going to get 49y plus 14x minus, so that's going to give us 14, and then 3 times 7 is 21, and carry the 1 from earlier on. Now I can eliminate the x term by adding these together. That's why I chose to multiply this one by 2, the coefficient of x that I had there, and this row by 7, so that I would end up with the same coefficient of x. Now if I just add the two together, my x's will eliminate. That's going to give me 53y. My x's disappear. And then adding these two together, I'm going to get minus 202. And that will equal 0. Solving this gives me y is equal to 202 over 53. That's a really ugly number, but we can just keep that nice and exact. And this is why generally we do it on the calculators. It doesn't matter how horrible the number is, it's often much, much quicker to do it that way on your calculator. Okay. We've got our y coordinate, and now we can find the x coordinate. Ordinarily I would substitute this into there, but we haven't got nice numbers, so I'm just going to work through solving this simultaneously again, mostly for a bit of practice, but also because I don't want to substitute that into my equation. So let's do this. This time I'm going to multiply the top one by 7 and the bottom one by 2, because then my y's will have the same coefficient. So on the top row I'm going to get 14y minus 49x plus 77 is equal to 0. And then this bottom line gives me, remember I'm multiplying it by 2 this time, 14y plus, multiplying it by 2 this time, 4x minus 64 equals 0. This time I'm going to have to subtract this bottom row from this top row. Subtracting because they're both positive. If I add them together, I would not eliminate the y. Top row minus second row, we know that that's going to give us no y's. 49 take away 4 gives me minus 53x. And then 77 take away negative. So again, be very, very careful. If you do it on your calculator, it will take care of all of your signs for you. So we're taking away a negative, so we're adding these. 7 plus 4 gives us 11. 6 plus 7 gives us 13, carrying the 1 from earlier. Gives us that. Solving, we get x is equal to 141 over 53. That will be the coordinate where these two lines intersect. Okay, we found our point of intersection. All we'll do to finish up is just write that as a coordinate to make our answer nice and clear. Okay, quick recap then. In order to find where two lines or curves or any two functions intersect, you're basically solving simultaneous equations. Eliminate one of your variables, either your x or your y, to find the remaining value. And then once you've got that, substitute in general, because that will be the quickest way to find your x value. We've not substituted in here just to show the two different cases and because we did have particularly nasty values of x and y. Thank you.